Alright, so today it's day 75. I solved one more lead code problem, also about try. And we have to implement a search word data structure. So we know that search is, for searching words, try is very efficient, so we're gonna do that. And it's the same, very similar to the previous problem. The main difference is that we have an added complexity, because they could give us a word character, the dot character. And if they give us the dot characters, it means that this character could be any. So we are not, if we're given day, we are searching only for the word day. But if we're given dot a, it means that we have to search for, as if the dot was every possible letter, right? So this is just doing a DFS over the tree, over the try. And the main intuition is that the only thing that it's gonna really change is gonna be the search function, and we have to do DFS like normally, unless the character is a point. If it's a point, then we're gonna do DFS over every neighbor. That's it. So let's do it quickly. We can implement, as the other time, a class try node, and we pass the init function self self.children. It's gonna be the dictionary, and we have self.end, the beginning is false, and we have self.root. This is the try, so it's gonna be a node, try node. Then for adding the word, if we want to add, for example, May, first let's say node is equal to self.root. Then the character that we want to add is gonna be equal to, no, not even that. We just iterate for a character in word, and we check the same as the other time. We just added so we added to node children. So we say node.children ch equals try node, because at the beginning is empty. But we only do this if it doesn't exist, so if it's not a duplicate. So I'm gonna say if not in node.children, we're gonna do this, and at every iteration we gotta move the node. So I'm gonna say node.children, and when we finish we have to set up this as true. Alright, so this is the same as yesterday, and for this one, the search function, we gotta perform DFS. The main intuition here of DFS is that we are not having like a normal linked list and like a normal binary tree, because a normal binary tree, what we did was we take a node and then we compute DFS over left and over right, and we stop when the root is none, right? But in this case, we are having like a word, so we can understand every character as a node, because every value is going to be associated with a node. So we can have like an auxiliary variable, which is going to be I, and we pass an actual node. And the stopping condition would be if I is equal to length of word, then we're going to return whatever it's in that. Essentially it means that we are in the last node, so we iterate over all the word, and we want to know what was the attribute end saved at that node, because if it's false, we gotta return whatever the attribute was, so we gotta return node.end. If this is not the case, then we gotta do DFS like a chain, like normally. So but this is only if it's not a point. So I gotta say, so I gotta get the character, which is just word I, and I is the pointer that moves at every time that we advance characters. So I'm gonna say if character is different than a point, then we're gonna perform DFS over the next. Okay, so I'm gonna say, but before performing DFS, the issue here could be that what would happen if we have a word, but we want to iterate the try, but we don't have enough nodes. This means that we want to find a word that is longer than that word in the try. So in that case, it's gonna return none, right? There will be no child to iterate over. Because normally we would say like next is equal to node.children, and we pass ch. But if it doesn't have it, like it doesn't have this entry in the try, it's gonna be an error. So we just have to do .get. This is a Python thingy, and this could be none. And if this is none, it means that we have to return false, because we are not gonna find the word because it doesn't exist. Cannot, yeah. So I'm gonna say return false. What can I return? True or false? What would be the logic? I think I'm gonna return false. Yes. If next is none, I gotta check this logic, but I'm gonna let it as it is. Otherwise, I'm gonna return DFS, because this is a normal character. We know that this is not a point, so we gotta do it over the next children. So now we are passing I plus 1, the next character associated with the next node, right? Because we are changing the node here, and that's what we are passing. And if it's a point, then we have to do a for loop, because every dot can have any value. So it means that we need to check every children in the dictionary of the current node. So I have to say for next in node.children. But the thing is that node.children is the dictionary, and I want to get the associated values. I want next to be the nodes, not the values. So I'm gonna say the values. I mean, this is because it's a dictionary, and it's key, and the values are the nodes. So that's why it makes sense here. And then we're gonna perform DFS, right? I'm gonna perform DFS over I plus 1 and next, and we're gonna return whatever the value is, which is gonna be could DFS be, I mean, what if node.children.values is none? That could be a case, because I only check it here. So if it's none, if it's either none or false, we're gonna skip this condition. So I can say if this is the case, if it's true, so it means that if it's either true, right? What I want to avoid is that it's false or none. So if this is this, it means that it's neither false or none, because it cannot be anything than none. Like if it's not none and false, it means that it's true because of the logic here. So we're gonna return true. And if we finish and we didn't return anything, it means that we never entered to this condition. So there will be like two possibilities. We are finding like a string that is longer than the possible string saved in the try, or that the last element is gonna be, I mean, you can pass like, because you don't have enough characters, or you don't have you have enough but it's false. The last element is false, so it means that the prefix exists but not the actual word. So I'm gonna return false, and we gotta run DFS over, at the beginning I is gonna be 0, and we are gonna iterate it all the way to what? We're passing the node. At the beginning is self.root. Okay, I always have an error with the syntax. What is the error here? Okay. All right. So that was it for today.